I'm Dave Fashion4, Instructional Math Tools, West Melbourne, Florida. This is part 2 of computing complex numbers. In this presentation, we'll first discuss circles and spheres required for recursive equations. We'll look at the Mandel-Flash fractal log more in detail, including the horizontal and vertical reflexive properties of the log. And we'll look at a tool that I wrote called a baby generator, and we'll learn how to operate it, and we'll look at the menu, and you can learn how to generate a data file that supports the graphics. I'll also provide the source program to you free of charge at the end of this presentation. In Mandelbrot's world, everything occurred within a circle of radius 2. There was nothing of significance that occurred outside this circle. I'm going to play a little video here. And what we'll see, of course, is that the Mandelbrot baby is a two-dimensional graphic. And as such, it fits very nicely on a two-dimensional plane. There's no left side or right side. It's flat. And the circle works quite well. But if you're going to think about generating a three-dimensional Mandelbrot, such as shown on the left here, you need more than just a circle, because that recursive equation needs to operate within a more or a less restraining environment other than a circle, and a sphere of radius 2 works quite well. Now, if you notice, the end of the Mandelbrot can be seen on the surface of that sphere right there. That is the proboscis, the ending of the proboscis, which basically occurs at x is equal to -2, which shows you that it is a sphere of radius 2. If you're going to be talking about a three-dimensional Mandelbrot, we're going to be moving into the world of spheres versus circles. The sphere that we saw previously is now fully utilized by the Mandel-Flash fractal log, in that to incorporate the recursive equations that generate the babies that make up the log, the circle has been expanded to a sphere. If you'll notice, it does not cover the entire log, and that requires, if you want to process some of the upper or lower portions of the log, you literally have to move the sphere up and down the 45-degree axis of the Mandel-Flash fractal log. But for now, we're going to keep it around the center point, and it is sufficient to generate all of the babies that make up the Mandel-Flash fractal log. This is an example of one of the central babies in the log. And so that you can see that the sphere is sufficient to be able to generate all of the babies that make up the central portion of the log. So the 2D Mandelbrot baby has been transformed into a 3D Mandel-Flash fractal log by extending the z-axis, both in a positive and a negative direction. The z-axis, of course, is representing the new imaginary axis that's been added to make it three-dimensional, called I prime. And if you'll notice, the black at the end of the wings, while they're terminated here in this picture, actually go on to infinity. And the reason why they're not shown here is we would have to take the sphere and we'd have to move the sphere up the axis to generate the other portion of the wing, and we'd have to keep moving the sphere all the way to infinity to show this entire stretch. But it's there. It's been evaluated in amounts of 10,000 units and more, doing quite well as it goes out to infinity. In this demonstration, we have stripped away one side of the log so that you can see some of the internal structure. In this case, over here, there are 6 babies shown. However, the log is solid babies. These are just the ones that are significant, and we'll explain that in a minute. And this is the other side also. So what we'll do is I'll start these little videos and so you can see both sides. And this demonstrates what we're going to be talking about with regard to a reflexive property. And that is to say that this baby is exactly the same as this baby, and this baby is the same as that baby, and this baby is the same as that baby. But this baby is not the same as that baby, and this baby is not the same as that baby. Keep in mind these logs have been degraded because we had to strip off some of the layers so you could see what's going on inside. Now what we're going to be showing here is how we can put the covers back on the Mandelfash fractal log. I'm going to start a little video here. Might have to speed it up a bit because it takes time. If you'll notice on the left-hand side here, the cover, the graphic cover comes on, and it's not color-coded yet. We have to wait until it gets completely installed before we can apply the standard coloring. Try to move this up a little bit here. And so now we're starting to apply the standard coloring. A little more on the reflexive property. First of all, notice that this log is exactly opposite to this graphic. This graphic shows the back babies here, and the back babies are actually there. So this log is flipped, but we can keep it straight. So it turns out there are 6. We're showing at least 6 Mandelfash babies. Now there are an infinite number of them up and down this log. Obviously, we're just showing the significant ones, the ones that literally make a 90-degree pattern with each other, 90 degrees, and they're connected. This one is connected to that one, and this one's connected to, they actually reach out and touch one another with the feathers at the end of their little wings out there. And so what we're going to be talking about is number 2 and number 6. See, number 2 and number 6 are identical to the original Mandelbrot. Okay, so the original Mandelbrot is actually number 2. And then when you expand the original Mandelbrot, the first thing you notice is that there is a horizontal Mandelbrot that appears that's exactly the same. So 6 is exactly the same as 2. And then what's surprising, of course, is that if you continue on with the extension of the original Mandelbrot, you have this number 5 baby as to touching the feathers of the other one and starts to come out this way, as well as one that touches the feathers here and starts to grow out that way. So we have a pair of back babies. Now the back babies are not exactly like the Mandelbrot babies. They're a little deformed. In fact, as you go up the ladder or down the ladder here, they get more and more deformed. The closer they get to the black wings, the more deformed they are. The closer they are to the original Mandelbrot, the more perfect they are. For example, the proboscis, which appears plainly in these two, starts to disappear as you get closer to one of these that has a very small proboscis. So you can see how it degrades as it gets away from center. So this is the back baby. Back baby is made of number 1 and number 5, a vertical and horizontal. There's also an extender up here, which is this guy right here. It's not really a whole baby, but it offers a conclusion to that stair step. And then this, of course, the center is like we talked about, number 2 and number 6, center baby, and the front baby, number 3 and number 7. And they have their own extender down here also. Okay, so why are we talking about that? Well, there's a tool, a baby generator tool, and here's the tool menu. And if you type in a 0, you'll get the back extension. You'll get this guy right here. If you type in 1, you'll get the back baby vertical, this guy right here. If you type in 2, you get the center baby vertical. You get this guy right here. Type in 3, you get the front baby vertical. 4 will get you a front extension. 5 is a back baby horizontal. And 6 is the center baby horizontal. And 7 is the front baby horizontal. So that's how you can, on the tool menu, simply select a number and you can draw one of these. And we'll show you what that looks like in a minute. With regard to the front and back, again, this is the Mandelfash fractal log. This is the two-dimensional plane, the XY plane, that the original Mandelbrot lives in. And this is the extender plane. The Z goes out in a positive direction and back in a negative direction. And it represents the I prime, which is the additional imaginary axis that was added to the original Mandelbrot. So when we say front, we're talking about out on the positive extension of the Z-axis. That's the front, which is over here. And we talk about the back, that's toward the negative extension of the Z-axis going that way. And this whole wing, by the way, is at a 45-degree angle. Picture a board or something leaning up against a wall at a 45-degree angle. So as you go up this, the babies are basically getting further away from you as they go up the 45 degrees. What you're looking at here is a fairly low resolution output of the tool, of the baby generator. In this case, we typed in the number 2 option to get the center vertical, and this is what you get, this guy here. When you type in number 6, center horizontal, you get this guy here. And it turns out this guy is exactly the same as this one. Those are duplicate babies. And since they're at the center, This is the original Mandelbrot right here. And this is the sibling, the horizontal sibling of the original Mandelbrot as a result of the 3D expansion. Now here's our menu again. We got the front and the back. Now if we, and we already did 2 and 6. Now we're going to do 1 and 3. Well, 1 and 3, 1 will get you this vertical here, and 3 will get you this vertical here. So there's the vertical in the back of the Mandelbrot, and there's the vertical in the front of the Mandelbrot, number 3. And then we do the 5, which is the back horizontal. It adds a horizontal to the vertical. And we add a 7, which is the front horizontal, to the front vertical. And you can see what's starting to happen. They're starting to touch feathers, and they're starting to form their 90-degree perfect squares. Beautiful. Not only do we have a perfect 45-degree lean to the Mandelfast fractal log, but we have a perfect square, a perfect 90 degrees, touching very lightly at their feathers, right here and here, and here and here. Perfect squares, while they're being slanted at 45 degrees. Very interesting graphic. Now here's the extensions, this extension up here and extension down there. That's what that is, and that's what that is. That's option 0 and option 4. Here's the family portrait, the extensions, the 2 perfect squares, and identical babies here and identical babies here, but these are not the same as that, and these are not the same as that one. And this set is exactly inverse to this set. So whatever is degraded on this one, it's perfect over here. But the degradation on this set of babies is perfect over here. Very interesting graphics. Now here is the actual tool, and this is the actual menu of the tool. And I'm going to play a video here. And this is the actual output. So it comes up and the cursor is blinking, waiting for an input. So you type in 6. You want to see the center baby. You want to see the original Mandelbrot. Now it wants to know what resolution you want. A 0 resolution, 1, 2, 3. So it types in 3. Now 3 is high resolution, and it takes a long time to generate a 3. So you have to be aware of that. Entering the drive letter where you want the data to be put, and also the name you want inserted into the file so that you'll be able to identify the files. And here comes the data. Each line on that output is a point being generated to form the baby. And we'll go on to the next slide here. This is a CSV file. This is basically a special case of a spreadsheet, Excel spreadsheet. It's oriented to be a text file, a data file that can be loaded into an Excel spreadsheet. The CSVs simply have, in this case, an X with a comma, and a Y comma, and a Z comma, and a color code. And it takes that text string and puts it into this kind of formation in a CSV file. And I'm going to start this little video, and it shows you that it explains that the first column is X and Y, and the third column is the Z, which is the extension, imaginary extension. And D is a color code only defined inside the program to whatever you want it to be. And in each of the data files, they have 100,000 data points. So this is the first data file with 100,000 data points. And after 12 hours of processing, again, we entered a 3, which is a very high resolution view of a baby. Only 12, with 12 hours of processing, it has generated up to 1566, which is, we started at 1500. It's generated 67 data files. Each of the data files has approximately 4 megabytes. And we're talking about a total of around 268 megabytes in 12 hours of processing. And here's what we got. This 12 hours of processing. It started here and worked its way all the way over to here. With 67 data files. Produced about 67,000 data points. Right here. So we let it run. Got some more files up to 1966, 1967 actually, 1967, which is 468 files. Well, that's a total of 468,000 points. It's been running for 4 days. And each CSV file has 4 megabytes, and a total of basically 1,872 megabytes. That's a lot of data. And here's what we got. We're not through yet. We're only 60% done. It's been running for 4 days. But again, we chose number 3, which is a high resolution. And that's important because if you wanted to zero in on something, if you wanted to look closer at this one, you would want that kind of resolution so you could go in to see what's going on. And we'll let it run. 2,304. That's a total of 805 files for 7 days. It ran for 7 days. 80 million data points. 805 files of 4 megabytes. 3,220 megabytes of storage. And here's what we got. We're about halfway through the body. And that's for running for 7 days. 70.92% done in 7 days. Straight processing. Here's the completed baby. This is the Mandelbrot baby. This is also the Mandelfash baby number 2 center. And we selected the 3 to get the greatest resolution. But it cost us. It cost us how many days? 10 days. 10 days of processing to get resolution 3, which is accurate to 0.0001. But it does take time. We could have chosen number 2 or number 1, and we'd been done within, sometimes within as soon as a minute. Some of the other ones take a little bit longer, or 15 minutes, or perhaps maybe even close to an hour. But option 3, you got to settle in for a long winter's nap. But this is what you get. High resolution Mandelbrot baby. And this is generated from the internals of the Mandelfash fractal log. I would encourage you, if you are so inclined, to download the baby generator. Simply go to worldoutsource.com/baby_generator.txt, and a text file will be downloaded to you. It's a plain vanilla text file. It happens to be in Visual Basic. It's the source text, and it will load directly into Visual Studio, into their console app, .NET Framework application in the Windows operating system, and will compile quite nicely, and you'll be running your tool within minutes after downloading it if you have Visual Studio and if you have the .NET Framework. Otherwise, if you don't have those kinds of components, I recommend you download it anyway. It's a text file, And if you're using some other operating system or some other language, go ahead and adapt it. Go ahead and make the changes. Because if you do that and it runs in your environment, I'll be happy to upload it to this internet source, and others will be able to download your version and be able to run it on their operating system and utilizing the programming language that they are more familiar with. Keeping in mind that we're going to offer no liability whatsoever, no warranty. It's just as is. Whatever's on there, you can just, it's your responsibility for the execution and the download of these applications. So, if you want to know more about the Mandelflash Fractal-Log, there's the fractal-log.com. On fractal-log.com are all the videos, including this video. And but if you want to download the tool, the Baby Generator tool, feel free to do that. Just type in worldoutsource.com/baby_generator.txt and it will download quite easily. Thank you for your time, and I hope you enjoyed it.